Good morning, everyone. Welcome to our discussion on CPU scheduling algorithms. In the previous lectures, we have already talked about different scheduling algorithms under preemptive and non-preemptive. Today, we are going to talk about the multi-level queues. When we talked about first come, first serve, shortest job first, and other scheduling algorithms, we have seen that we were maintaining only one ready queue and one running queue. And then all the processes were given in these two queues, like one ready queue, and then we were taking the processes from the ready queue and giving it to the running queue. However, all the processes that we were taking from the ready queue and giving it to the running queue could be of different varieties. So what do I mean by that? That means the processes could be of different types. The processes could be the system processes, the interactive processes, or the batch processes. So the system processes are nothing but that are generated by the operating systems. And then you have the interactive processes. So the example for the interactive processes could be like you're playing some interactive video games or playing some kind of chess with the computer. And then you have the batch processes. So if you recall, when we were discussing about the type of operating systems, we talk about the batch processing operating system, where it will try to club a lot of jobs together for processing. So whenever you have different types of processes, so we will also maintain different types of queues for processing these processes. So that means if we have any kind of a process that is generated from the system, we will try to put it in a system process queue. And if we have any process from the interactive process, we will try to put it in this interactive process queue. And similarly, if there are any kind of processes like that are like background processes, so or the batch processes, we will put it in the batch queue. Now, in this one, all these multiple queues that we have, the system processes actually have the highest priority. So whenever you have any process in this system process, so these processes will be executed first than the batch processes which are in the bottom queue. So which is having the lowest priority. Now, whenever these queues are maintaining some processes for execution, they will also maintain their scheduling algorithms. For example, system process will actually process their processes based on priority scheduling algorithm. Interactive processes will process their processes based on round robin, and the batch processes will process their processes based on the SRT. Now, these scheduling algorithms could be different or it could be the same. It depends upon the hardware and the operating system that you are using. And you can also choose. So there is nothing fixed that you have to use only the priority scheduling algorithm for system processes. You can also use the round robin here or shortest job first. It's all up to you. However, you need to notice one thing, that this is the system processes are always of the highest priority. That means any of the processes that is coming here, they will get the CPU execution first rather than the interactive processes or the batch processes. So what is the drawback of these multi-level queue scheduling? So the drawback for this multi-level queue scheduling is again starvation. Suppose if you have a lot of processes that is in the system process, then all the processes will get executed here. And only once all the processes in the system processes are executed, only then the interactive process will get a chance to execute on the CPU. Okay, so that means all the processes that are in the interactive process queue and the batch process queue, they always need to wait for the system processes to finish their job first. So this is the drawback of the multi-level queue scheduling. Now, in order to resolve this problem of multi-level queue scheduling, we will have something called as multi-level feedback queue. So if you notice here, we already have the same queues. We are maintaining still the same queues like Q0, Q1, and Q2. However, we are trying to provide a feedback link from each of the ready queue to the other ready queue. And then the ready queue, which is on the top, is of the highest priority, and the one which is at the bottom is of the lowest priority. So what do I mean by that? So whenever you have any of the process that comes into this queue, in the ready queue, then that process will be executed for 2 quantum cycles. Now, for each ready queue, as we mentioned before, will have its own scheduling algorithm. Similarly, the CPU will also have a different kind of quantum mechanism for each of the process that is received from the different ready queues. For example, whenever you receive the processes from the ready queue 0, they will be executed on the CPU for a quantum of 2 units of cycle. And then the processes that are received from the ready queue 1 will be executed for 4 quantum of cycles. And similarly, like whenever you have the processes in the ready queue, they will be executed in the first come and first serve manner. Let's try to see how it happens. Suppose you have one of the process that enters in this ready queue, and that process will get executed for 2 quantum cycle. And if it is completed in 2 quantum cycle, it will exit. Otherwise, the process queue will actually send this process to the another ready queue level. So that means it will not try to execute the whole process for a long duration of time. If there is a long duration of time that is required for execution, it will try to tell that process, you can go to the other queue and then you can wait there and get executed. So once the process gets to the other queue, so here the process will get executed for 4 quantum of cycles. So if the process is completed in 4 quantum of cycles, it is completed and it will exit. Otherwise, what it will do is it will just try to be sent into the lowest priority queue, that is the ready queue. Now, in the ready queue, you will get executed on the first come, first serve basis. So again, remember, like we can use any kind of algorithms here. So once you have the processes here, then the processes will get executed in first come and first serve basis. So now remember, like all the processes in the ready queue 1 are scheduled only when no processes exist in RQ0. That means only when all the processes in the ready queue are executed, only then the processes in ready queue 1 will be executed. And when all the processes in the ready queue 2 are scheduled or processed, only when no processes exist in the ready queue 1. Okay, so this is how it happens. So you need to finish the processing of all the processes in ready queue 0, and then the ready queue 1 will start processing its processes. Once both the processes are emptied, that means there are no processes for execution in ready queue 0 and ready queue 1, then the ready queue 2 will start executing. So this is how your multi-level feedback queue will work. However, the problem with the multi-level feedback queue is the processes will get settled into the lower level of the queue and may be starving. So as we said, whenever you have a new process that comes in, it will get executed here, and then it will be sent to the bottommost queue if they have not completed their execution. Imagine that all the processes are here, and then still there are new processes that are coming. So until and unless all the processes get completed in the ready queue 0 and ready queue 1, so ready queue 2 will not start executing those processes on the CPU. So this is the drawback of your multi-level feedback queue. So thank you everyone, and see you in the next lecture.